Hello there. This is Mr. Anderson for Kellogg Community College. Today we're going to be looking at just doing some basic entry of binomial distributions. Problem number 3 has several parts on it on page 277 in the elementary statistics books by Blumen. And what we're going to do is take a look at these formulas here, and we are going to just kind of follow step by step what they have in the book and take a look at how to type this into a graphing calculator. TI-83 is what I'm going to be emulating, and if you have a newer TI-84 calculator, you can click on the mode key, scroll to the second page, and change it from math print to classic, and that will allow you to see kind of what I'm typing here. Alright, so the first thing I'm going to do is, here's the formula just in general on the screen, and what I'm going to do is take a look at the first problem, which gives us the n value, and the n value in this case is going to be 6, and we are going to choose 3 items, which means that I'm going to have 6 minus 3, which in this case 6 minus 3 simplifies down to just 3. Your p-value, or the probability of success, was given in the problem as 3%, or 3/100ths. And we're going to raise this to the x power here, and the x power in this case is going to be 3 because we're choosing 3 from our original x. And then you'll notice our n minus x, this would be 6 minus 3, which in this case would simplify down to 3. And the q, which should be our complement to the success, this would be 97%. Whoops, typed the wrong numbers. Now, what we'll do here is take a look at this on the calculator. So let me bring the calculator over here. Get to a clear screen. I'm going to really ask you to be very careful when typing an equation like this, because you click 6, and click the math button, click left to turn on factorial. Now, what's important about this is you're going to now divide this entire denominator. The entire denominator has to be in a parenthesis. If it's not in a parenthesis, then what's going to happen is that it's going to give you the wrong answer here. So I'm going to go 3 math factorial, like so, multiplied by 3 factorial again, putting little factorial numbers on there. So this does the problem correctly, multiplied by 3% raised to the 3rd power times 97% raised to the 3rd power, and we get an answer of, oh no, the answer is too small. But in this case, it's going to give us scientific notation. Now what I'm going to do here is, when I do the scientific notation here, the calculator says, let me bring that back up here again, this 4.92 e to the negative 4. This is scientific notation, which means that the decimal has to be moved 4 spaces to the left, and that means it's going to jump 1, and then 2, 3, 4, so you'll need 3 zeros in front of it. So the answer is 0.000. Now from the calculator, you'll notice it said 492, so that would be rounded to 5. And so that's how we get a very small probability of this actually happening. If you only have a 3% chance of success, out of your 6 items, choosing 3 winners with only a 3% chance of success, the odds of that, the chances of that happening are very, 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 very small. Because that's what binomial distribution is asking. If you have 6 people, and you chose 6 people at random, and one of them has a 3% chances of your success, what's the chances of having 3 people in this group winning? And it's less than 1%, which would be 0.01. So it's 5 10,000ths. So it's just not a very good probability here. All right, so moving on to the next problem here. I'm going to scroll down a little bit. So in the next problem, what we have is we're going to be picking 4 people. The probability of the success is going to be 18%. So 18%, and we want the chances of X people to have this success rate. So in this case, our X is given to us as 2, so those go in for all of the X's. So there's an X, there's a 2, there's a 2 here again. Now n is the number of people we have, so that would be 4 minus 2, and 4 minus 2 is just going to be 2. And therefore, this in the numerator here, or the exponent, 4 minus 2, is going to be 2. All right, so with that in mind, we are going to now figure out what the Q value is. It's the complement of the P, and that 0.18 is going to be 72, because that makes up to 100%. And making sure I don't, oops, it is 82, sorry. Didn't carry the 1 so well. Let us now give you the formula. Get my graphing calculator back here, and there we go. Now, what's nice about the graphing calculator is that you can click second enter and it will kind of recall what you typed in before, and I'm going to use my cursors to move left and right and type over these values. So that's 4 factorial, and this is 2, and this is 2. This is going to be 18. You can really save yourself some time here. And raised to the second power, and then what we're going to have is 82, and this is raised to the second power. Okay, so we'll get an answer of 0.13, and looks like I typed that in correctly here. So 0.31, so roughly 13%. If I have a 13% chance if I'm picking 4 people and I want 2 of them to be the winners or success. So to get 2 out of the 4 people in this group to be winners, the random chance of picking that would be 14%. So I'm going to go over here and type that in as my answer, 0.131, or roughly 13%. Okay. Now, I'm going to do one more here. I think after you start to see this, you'll start to see some of the patterns emerge. So let's do one more for good measure. In this case, we're going to have a sample group of 5 people. All right, and 5 people. We're going to choose 3 of those 5 people, and so all of our X's are going to be, we want 3 of those 5 people to be our successes, so all the X's turn into 3's here. So we're picking 5 people, we want 3 successes, and our success percentage in this case is going to be pretty good, 63%. So what we're going to do is 0.63, and that means the complement of that is going to be 0.37. Making sure I don't make any silly mental mistakes. Now, what this means is that our sample size, 5, is going to have to subtract the number of successes we want, which is going to be 3. And we'll put those in both of these spaces, 5 minus 3. And then we subtract the 2. 5 minus 3 is 2. And then this 5 minus 3 is 2 as well. And we're going to go back to our calculator. Go back to the calculator. I'm going to hit second enter. And after I hit second enter, I'm just going to change these numbers. I'm going to change the 4 to a 5. I'm going to go from the 2 and then the 3. So 2 times 3. Then I'm going to have 0.63 and raised to the third power. And then I'm going to have 0.37 raised to the second power. All right, so hit the enter key, and it looks like my chances of that happening match what you should get to, 34%. So if you're choosing 5 people at random, and the chance of one of them being a success is 63%, then your chances of getting 3 of your 5 people to be a success is roughly 34% if you chose that at random. So I'm going to type that down as my answer here. So 0.342. All right, now please make sure that you show in your homework, since you're going to be doing this on the calculator, show in your homework what you're typing into the calculator, especially on tests. You're going to want to do that in case you make a silly typo on your calc, or you just a miscalculation. At least you get partial credit for showing your work. All right, so hopefully this will teach you a little bit on what to do with the graphing calculator and how to do binomial probability here. So thank you.